Okay, let us go ahead and get ourselves started today. Today we will do several different things. We're going to go ahead and fix up some problems people have been having with their Dynamo installations. So we're going to take a look at the version you have installed and how to install a newer version that may work better for your machine, and think about how that impacts some of the different scripts we've been working on so far. So we're going to start with some version control things, and then we're going to go ahead and introduce the assignment one that we'll be working on together, and continue pushing ahead with just more controlling of different instances of families, and creating points and surfaces, and just using Dynamo to create some interesting geometry. But before we dive into the new stuff, I just want to get everyone on the same page, including the folks who are listening to the video. So let's kind of summarize what we have learned. Okay, we have learned that there are several different interesting problems working with Dynamo, which is kind of an experimental environment. And there's ways to solve some of those different things. So one problem that we discovered is that we have been working with different versions of the program on the machines here in the computer cluster. So let's tell you how you know, or you can find out which version you are working with, and then you can update as needed. Okay, so I'm going to switch on over to the Dynamo environment. Okay, I'm hanging over here looking in Revit. And in the Dynamo, when it's open, if you pull down the Help menu, okay, if you see an About choice, chances are you are working with the version 0.63 and some suffix after that. If you don't see the About choice, you're probably working with 0.62. That seems to be a feature they added in the 0.63 release. Okay, so if you can take a look there and make sure you're working with some version of 0.63, we'll all be on the same page. It turns out I've been working with 0.62, and the TAs and I found that out last night in terms of trying to figure out why set family instance parameter was showing up on some machines and not on other machines. As well as we were having an interesting symptom where sometimes points would report a length as opposed to just reporting a numerical value. And that was happening on some machines and not on other machines. And it turns out it's all just due to the version. In the latest version, they went through and changed some things. So we're going to look at first just sort of updating some of our scripts to take advantage of, or to fit in to the scheme of how things are defined in the newer version. So 0.63 is where you want to be today. If you need to install 0.63 and you're not here in the room with us, you can either download it from the Dynamo site, or I even uploaded the installer to the coursework site. You can find it out there, the 0.63 installer. The other place you can get it if you want to get it directly is just directly from dynamobim.org. And from that side, you can download the 0.63 version. That's the one that we are working with today. Now, you'll also hear us talking about a 0.7 version, and we're considering moving ahead to even a newer version. And the reason we're thinking about that is some folks who are working on 32-bit installations of Windows are having troubles opening the 0.63 version. So what is happening is that the 0.7 version seems to be a little bit better for working on those 32-bit installations, so we may move to that newer, even more bleeding edge version of it. If you want to install that one, and I wouldn't recommend doing it just yet, we're sort of testing it to make sure that it consistently works for what we want. What you do is, on the Dynamo BIM download site, instead of just clicking the big blue Dynamo button, scrolling on down, and you'll find the Dynamo 0.7 install down there. So keep kind of put a hold on that one. We'll kind of confirm that it is worthwhile moving to that version. And if we do need to move to it, it's a little more experimental. It's where they introduce all the latest, greatest new features, and it seems like they sort of introduced a fix to the 32-bit problem. But before we all go moving there, let's kind of confirm that it's actually working for the few folks, and then we'll kind of all move there together. So if you can, just get yourself on 0.63 today. Yes?
I just read on their site that 0.7 version could be installed parallel to 0.63. Just
So
for test, they asked us to test.
So we can put it in there perfectly. Excellent. Okay, so we can go ahead and install those two different things simultaneously. Okay, I did go ahead and download it. Okay, actually I won't do it now. I'll do it after class. So it sounds like there's not much of a penalty for doing that. So go ahead and if you can, at least get yourself up to 0.63. And then let's talk about really what the differences are. Okay, let me kind of close that up. There are probably many different differences to be discovered between all these different versions, but let me kind of tell you about the ones that we do know about in terms of the different versions. Okay. One of the big differences is that, okay, the set family instance parameter is no longer there. We now have something called set element parameter, which actually works about the same. So we basically feed it in sort of an instance or a type of a family. We give it a parameter value, or we give a parameter string kind of describe what the parameter is, and we feed it a value. I'll see how that actually affects some of our steps in just a second. The other one that it sort of affects, though, is just the whole notion of the x, y, z. When we say return the x of a point or return the y of a point, it used to return numbers. Now it's returning lengths. We'll talk about how we go ahead and fix that too. So let me go ahead and just patch up an example, okay, from that old sine wave window example that we were working on last time. And then using that as an example, we can sort of continue to patch other scripts. Okay, but I have some new scripts uploaded there into the session 4 folder. So if you haven't done it yet, please do that. Just on Dynamo or out on the coursework site, go ahead and download that session 4 Dynamo examples. It has the newer versions. Okay, as well as, if you want to, go ahead and grab assignment 1. We'll get to that too in just a second. So let me come on over here, back over to the Dynamo environment, and let's just kind of start with that whole notion of how these, slightly different scripting environment works and the changes you might need to make to some of your kind of scripts to make them happen, to make them work the way we want. So if I go and open just that window instances sine wave, okay, that was that example we worked on last time, and I'm going to open the script for it. Let me go through and go to the add-ins. Open up the Dynamo scripting language. Okay. Actually, let me do two things. I'm going to start by just opening the old script, and we'll sort of see what the problem is versus the new one. Okay. If I open the old one, and this is going to be in the folder from last time, not from this time, you'll sort of see what the problem is. Just want you to kind of see what the problem looks like so we can then kind of work against it, or how to solve it. Kind of zoom that around a little bit so that looks a little bit better. Going to pop that up. I'm going to run it. Okay, and you're going to see a lot of nodes turned red, and we'll talk about why that is. It's going to start with the sine wave node is turning red. So that's the first one that's giving us some sort of error. If we got to take a look at the error, we can try to backtrack and understand what it is. And it says, it's unable to cast the object of type container to a number. Okay, so it's a little mysterious as a message, but let's go on back upstream and sort of figure out what's flowing into it. You'll see that we have this whole notion of 8.8 feet, 7.99 feet. Okay, so it's reporting a length as opposed to reporting a number. And the problem is the sine wave function is kind of choking on that. It's just not quite sure what to do with the feet. Depending upon how your settings are set on your environment, that may be meters as opposed to feet. You can control that. It's actually just up here in the settings in Dynamo. You can really control whether you want to see things in terms of feet or whether you want to see things in terms of meters, and even how many decimal points you want out there. But one problem we're having is we need to go through and just sort of take these x values which are reporting as feet, okay, and convert those just into plain numbers. Okay, and it's always funny. We have all these fantastic functions over here. There ought to be some really good function that'll convert a length into a number. It sounds like a really good function to have somewhere. Okay, but it turns out there isn't one, at least not one that I could find very easily, but there is an easy way to do it. And it kind of harkens back to what we used to have to do in Revit when we did formula arithmetic and you had mismatched units. Okay, if we have a certain number of feet reported, okay, like 19 feet, and I want that to be 19 as a number, what I need to do is basically divide it through by 1 foot. Okay, and it'll strip off the unit. I saw that laugh because it's just that silly, but it sort of does work. So let me try that. We'll say divide. Give myself a little divide node, and what I'm going to do is I'm going to take that x value, kind of plug it into the divide node. I'm going to go through and actually put in, there is a concept called a length. So I'll take that and I'll put in here like 1 foot, and I'll string that over to here. And now, let me go ahead and run it. You always have to remember to run. When I turn off my run automatically, I have to remember to kind of rerun that thing. Okay. Now that is a string of numbers, or a list of numbers as opposed to a list of things. So just dividing through by the unit was enough to do it. So once we were able to do that, we can then instead pipe that through, I guess, to the multiply, because I'm going to put that little amplification onto it. Okay, and if I run that, you'll see it does what it wants to. So when you start having this issue of, oh, it's just not getting what it's expecting to receive, and you get the red box, the key is to kind of back upstream and kind of always be looking at what the preview is showing and see if you can kind of debug it that way. So for this issue of the values, okay, it's really just a matter of going through and dividing through and creating, stripping out the unit. Yes?
I pressed run updated version and I have now read also divide and multiply and all other. And it says sequence contains no elements, but they have length, but in meters.
Okay. Oh! So, yeah, so is your XYZ, okay, is that reporting in feet or is that reporting in meters?
The list is empty.
Oh, the list is empty in the XYZ?
Yeah.
Okay, so back up a little bit further and let's go back to this whole notion of, you know, this where it's reporting the family instance location. Yeah, yeah. Keep on going upstream and let's start with, you know, are you actually choosing a family? Yeah.
It was elevation mark.
Okay. So,
I opened file again.
oh, no, exactly. So, yeah, always go upstream. So the issue is, you know, if it doesn't have any instances, then we go back to selecting one of the families that you actually have placed in the project file. Yeah, so it's always this matter of going upstream. Are you seeing anything in terms of feet there? Are you seeing anything here in terms of the list of the different locations? Yeah, is that showing you some specific family instances? So it's always going upstream and kind of seeing what's happening there. Okay. The tail end of this, though, that we might want to know about is just this whole issue of set family instance parameter. It looks like family instance parameter is still operating, even though it no longer appears here in the list. Okay. Looks like they kind of left it around. A lot of times they'll do that with software where in order to not break things that are already existing, they'll keep on supporting that node, but they don't really give you that node as a new one to put in there. So let's just go ahead and fix it to the way what we want it to be.
We can't select fix 12 by 20 by 48 that you have. We don't have that one in our.
Oh, no worries. So what we can do, yeah, for me, if we open the project file, it'll be in there. If you just open the Dynamo file independent of the project file, then it won't be in there. So it's in that project file. And again, I wouldn't worry about it too much. It's one of those things if you do it in that order. So again, yeah, what you have to do is just open a project file that has that. Or if you want to, just go ahead and create a in your project file in the background. Just go ahead and kind of create some. It's really, yeah, it's, you know, there just has to be one available as a placed family inside the project. Okay. So the other node I want to take a look at back at the tail end here is just a set family instance parameter. Again, that one no longer exists, but they have one that works just about as well. In fact, it's even a little more flexible. It's like called set element parameter. You got it? Okay, good. Okay, so set element parameter and set family instance parameter, it actually works amazingly similarly. It's going to be the same. We're going to drag an element down into it. So I'm going to go way back over and grab that family instance, or that element, which is a family instance, over here. We're going to drag a string in, which is going to represent the parameter that we want to change. I'm going to drag the value in. In many ways, it's just the same. the nice thing about element parameter versus family instance parameter is it's more generalizable. So we could use that to really be saying type parameters as well as instance parameters. It's just it's just more generic. Okay, but it should do about the same thing. So when we get done taking that out, okay, that one should be dominated in logic, and we should be okay. So the script should be restored. We gotta put a little amplitude on the wave so it doesn't look so flat. I'll run that. Okay, and that's looking pretty good. So I expect that the windows are looking pretty good in the background. Okay, not too awfully bad. So those are the big things that we've learned so far is differences between 0.63 and 0.62. There's probably going to be some other ones that are going to turn up too, and we'll sort of try and figure those ones out as we come along. But in an experimental way, we'll just kind of keep on stumbling through and helping each other kind of get through some of the hurdles when we hit them. Okay, so let's just kind of pause there for a second. Give everyone a chance to kind of get caught up on that. So most people, you able to kind of get that? Excellent. Okay. Let us then go ahead and turn our attention to what the assignment's going to be. And it's not a hard assignment. I think you're actually going to realize that it's very familiar, it's very similar to some of the other things we've been doing. I should probably spell that right, shouldn't I? And what we're going to do is be working on a project that I call just ripples on a pond that the TAs and I came up with. And let's go ahead and just take a look at it and sort of see what it actually specifies. So if you go on out there to coursework and pick it up, what we want to do is actually just go through and create a grid of objects that's going to adjust their heights to reflect the distance from a target point. And you'll recognize that's actually somewhat similar to some of the attractor logic we've talked about. The idea is that we're going to have a whole grid of different objects, and based upon a point and the distance from that point, okay, we're going to go through and adjust the height of those objects. Okay, the analogy I'm going to use here is sort of like when you drop a pond or a pebble into a pond, how the ripples kind of come out from that point. And we're basically going to go through and try to adjust the heights so they do something like that. So we'll have kind of a grid of points. We'll go through and have a point that we're going to use as the insertion point where we would drop the pebble. And then we want to just kind of watch that ripple kind of cascade out there. And we can model that a couple of ways. We can model it as a sine wave or as a cosine, and kind of work with this amplitude, we can work with all these different things in terms of how strong that ripple effect wants to be. Okay. So that's what we really want to accomplish here, and in terms of doing it, what we want to do is just start by creating a rectangular grid of objects. In this case, I'm suggesting cylinder objects, which is just one of the standard mass families that you can load in there to put them on those points. Okay. Once you go through and create that grid of cylinders, the next step is really to create a point that's going to represent where the pebble would be, where you would actually drop it in there. Give it some sort of control so we can move it around using some sliders. And finally, it's just to go through and adjust the height of the cylinders to represent the ripples. So that's going to be a whole, we can start building it simply and build it up from there, but just by computing the distance away and then using that as the input to some sort of wave and then controlling the amplitude of that and the base height of that, we can go ahead and just make sure that the ripples kind of evidence right from the cylinders that are in the project. Okay, so that's really what the assignment's going to be. I'm going to also throw in there, just that little extra for experts. If this is all incredibly easy for you, and actually it's a pretty easy assignment. This is really more about just kind of getting it done in terms of what's going on. You could also consider this question, if you have the heights responding to the sine wave as they move on out, but it's kind of the same sine wave moving out kind of at a constant amplitude, you can start to think about really how could you diminish the amplitude as you move away. Kind of like the ripples really would do in a pond. You get the strongest ripples, and as you move further out, it would eventually damp itself out. Okay, again, that's just really extra for experts. So, if you're keeping busy with all this type stuff, super. You don't need to do that. If this is incredibly easy and you want to just keep on pushing it, feel free to keep on pushing it. It's really just all about playing with the environment and kind of learning all that stuff. and then ultimately want to submit your Revit project and your Dynamo file.
As for the grid, the shape of the grid, can we use set the shape of the grid to a round shape, or is it only possible for us to just use a square shape?
Let's think about that. It's actually sort of a very good question. You're sort of thinking about a polar grid.
Yes.
Sometime. Let us see. I know how to create an XYZ grid, but let's go ahead and experiment with that. In fact, what I want to do with this is even sort of play around a little bit kind of with this whole notion, kind of file that one away. We'll sort of do some stuff in class today to sort of build in that direction. Let's kind of sort of play around with that a little bit. Okay, so very good question, because I can think of doing that a couple of different ways. There's probably a real grid object, but if we're having trouble with the grid object, we could go ahead and create some concentric circles and then divide some points, on those circles. So we can do it that way too. Okay, so let's go ahead and just take a look at that, because I think that's really kind of a good thing to approach. How's this notion of the assignment? Sort of clear what you're supposed to do? I think for most of you, this will be, if this is an hour, I'd be surprised. It's just kind of going through the mechanics and connecting all the pieces together and stuff like that. But hopefully, you're working through that, and all the little hitches that come up along the way will sort of debug, how it's working in your own environment, and just make sure you have a first-hand feel for that. Okay, so let's go back over here, and let's just kind of start talking about building something like this. And as Anastasis suggested, we have code that does things like this, but we can go ahead and create it from scratch. I'll go and create something from scratch, but feel free to go through and beg, borrow, and copy code from other snippets and kind of combine them together, because that's actually okay. That's a well-worn principle in terms of what's going on. What I'm going to do to start this out is just kind of create a new project file. And please go ahead and follow along. It would be great to go ahead and just have you have the same experience, so you can even make some headway on the assignment as you go. And under that project file, I'm going to open the Dynamo environment. We'll see how that's going. Actually, let's check with you, Mr. Christopher. Any luck on the 0.7? Did it open for you?
Yeah.
So, interesting. Okay, so we have a little confirming data that Dynamo 0.7 works okay for 32-bit installations. I'll take 2 data points and declare it a victory. Okay, which is a little weak, but I'm going to assume that's good. So what we'll probably do is move forward to 0.7 as a class and start issuing the scripts in that format instead.
But a lot of names are different.
They keep on, well, that's the trade-off. So as we go ahead and continue this assignment, stick with 0.63 if that's easier for you. Okay, so let's go ahead and think about, creating a grid of points and how we could actually do this. We're looking at a grid which is just waiting to have some points dropped on it right now. The biggest element that we actually sort of play with is, let me see if I can find that XYZ grid. There's XYZ grid. Okay, that's going to get a rectangular grid. We'll see if we can kind of create a polar grid or something like that in a minute too. But XYZ grid, if I put that out there, here's what's involved in an XYZ grid. It involves these parameters. It is the number of points to create in the X, Y, and Z direction, the initial point in the X, Y, Z direction, and then what the spacing is between those points. So let's just go ahead and kind of set that up in a really flexible way for ourselves. So for example, I'm just going to create a number right now. 0. I'm going to go ahead and link that into the Z, because actually I'm going to deal with a one-dimensional grid right now. I'm just going to keep them all down there on the floor. Okay, and for the X and Y values, I can have a number slider. Actually, it would be more properly an integer slider. And we can kind of link those into the X count. If I want to have a perfectly even grid, so it always have the same number of points in the X and Y direction, I can use that, link that one integer slider into both of them. So I can do it independently, just depending on what you want to do. I'm going to run it automatically so far, just so you can sort of see the impact pretty quickly. Oops, I need to put some more stuff in there. Okay, I need to say what is the initial point for the X, Y, and Z. Really, what is the origin of the whole system? And if you want it to be at 0, 0, 0, we can again just link that 0 into there also. We can set it up as separate numbers if we want individual control, but it's okay. Just to do that. Okay, now we're going to think about our spacing, our x spacing, our y spacing, and our z spacing, which really isn't going to be significant since we're going to have 0. Oh, should I take that back? That's interesting. I am making a big mistake in here, as I often do. For my z count, 0 is not a very good number. I think I actually need one of the z's. I'm guessing that's going to work. Okay. Now let's think about our spacing, our x, y, and z spacing. Again, we can go ahead and put in sort of any spacing we want to put in here. We can put a number in here, or we can put a slider in here, or an integer if we want to. I'm just going to put a slider in here, a number slider. Okay, and again, now we can start to think about whether we want to have the same spacing in the x and y direction. Go ahead and okay, so let's see what we got here. I got a bunch of points. They're all hanging around at x. Actually, I take it back. Nope. Zero, 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 x. I got that. There. You knew they were there. It's just that they were all hanging off the screen so you couldn't see them. Let's go ahead and make that a little bit smaller in terms of spacing. The spacing is a little bit big right now. Let's make the spacing every 2 or 3 or something like that. Just something a little smaller so we can actually see them. Okay, so that's a relatively big grid right now. That's like 70, something like that. Maybe this is a little bit big for relative we want. I'll bring it down to like 30 or something like that. Just so we have a little bit smaller control. Okay, so I am going to pause there, and let's make sure that on your screens you can actually get the same sort of grid going in terms of just that much of the logic in here. Get yourself a basic grid going here with the ability to kind of control the numbers and the spacing. Again, from that grid, that's such an incredibly useful kind of primitive kind of chunk of code. We could go ahead and put circles, we could put cylinders, we could put cones, we could put whatever we want on there. Okay, so let us just pause there and just kind of give everyone a chance to catch up. So how are we doing on grids? Everyone got a grid? Looking good? Grids on the second row? Grids on the first row? Everyone's looking good? Excellent. Okay. Next thing up is the whole notion of could we go through and like put some sort of like an object on there. Okay, and in order to put some object in there, it's this whole notion of just selecting the type of object you want to put in there and then creating the family instance and then you're putting it at all those x, y, z points. So let's just go through that real quick. It's select and it's family type. And the other thing we have to do after that is create a family instance at a given XYZ location at a specific level. Okay, so we'll link the type on in there. We'll link the XYZs in there. Okay, we haven't really done a very good job of choosing what the object is yet. It's only going to be something that's available inside the project. So you can see what sort of things are standardly available in there. There aren't very many interesting things in there. You can put trees or something like that. But what I'm going to do is actually load in a mass piece just to kind of make that a little bit better for me. So here's where we would do that. So back over in the project itself, okay, you want to just basically load in a family. And again, we could do this with desks, we could do this with chairs, we could do it with boxes, or whatever we want to put in there. And how about this? Let's go ahead and load in. I tend to go after these little mass pieces, and I have arches and boxes and cones and cylinders and spheres and all that kind of thing. And what I'm going to do is make little houses. Nah, I'm just going to keep it simple. I'll go for the cone. So since that cone now shows up as one of the families over here, I think it should show up. I have to check this all the time. Sometimes I place them and then it shows up. Let's see what it's going to do. If I come out here and say mass, no, looks like it's actually not there just yet. So what I really need to do is to kind of complete this, I need to take one of those cones, just put it in the object, or put it in the project. So the parameters are available for that. It has a height and a radius. That's not too bad. Let's kind of take a look at it in 3D instead. Okay, so since I've placed an instance, now I think I ought to be able to get to cone. Actually, it might have been there before. Let me verify that. I don't want to mislead you. If there isn't one placed, I just didn't have the right name. Can I say cone down there? Looks like I can. Looks like it's a little upset about that. I think it probably has to do with the fact that there isn't one placed right now. Try running that. Yep. Let me try placing one in there and see if that makes a difference. But as you'll discover, I'm learning this as we go too, in terms of just really where some of the funny hitches are in this whole story. It looks like it has that error right now. When it's given me this error before, this is kind of an interesting one, and for me, what I tend to actually have to do is it's like it's trying to do something, but it's not doing it in there. What I often do in this case is just say, just create another family instance, put another version of the node in there. Actually, I could copy it in there, couldn't I? And take out the other one. Okay. But I'm not sure about the precise logic of that. Let's go ahead and run that. Oh, it looks like it's still running. Looks like it says it's empty. Oh. So let us think what's going on here. I'm sort of stuck in some place where it's trying to run. How you guys doing on your side?
It's okay.
You're okay on your side. I sort of messed it up. So you got that sort of, it looks like it's stuck in a loop of some type, right? It's got something weird going on. Because my run is not available. It's like it's thinking about something. Don't do that. Come back over here. Let me close this up and save it again. Yeah, save it. Hang on. Okay. See if I can close this up and reopen Dynamo. Okay. If you guys are doing okay and you don't need to reopen Dynamo, that's A-okay. You're doing better. Oh, maybe it's because it thinks I'm in the middle of placing a mass. That's interesting. Trying to figure out the modality of really why it is happy sometimes and not happy sometimes. Okay, let's try this again. Create family instance. So I'll go from the cone. I go to XYZs. Okay. Hopefully that's going to run.
Let's see how it looks back over here. I did a lot of generating of something. Oh, okay. For the cone size versus the cone height and the grid spacing and all that type of stuff, it looks like they're all sort of munged in there a little bit close. If I stop to think about this, I could probably realize that since the cone radius is 15, I need to have a spacing between all the different points much bigger, or shrink the radius, one or the other. Then we go ahead and I'll just increase the spacing between the points. So to do the spacing here, that's the number of them. That's the spacing. Try that. Do a little running. That's interesting. Oh.
The number of sides and cheap.
Oh, thank you. I changed the bounds, but I didn't actually change the value. Okay, so now they're all sort of doubled up. Now, there still is actually, I'm not sure if you can tell, there's a double up one in there where I placed one of them manually, and it's still kind of hanging around in there too. I can get rid of the manual ones if I want to and replace them again. Okay, so at this point, we have this big field of all the cones. We can change the values. Run that automatically, or run that. Okay, we're doing pretty good. At this point, we can start playing around and thinking about, trying to do something that's going to go through and start changing the height. But at some level, that's really the first part of the assignment, just going through and creating that grid so you can sort of slice it up there. Now, the interesting question that Hung brought up is really, can we also create a polar grid too? And let's think about how we can go through and do something like that. Because, again, that's kind of an interesting way of approaching it. Let's go ahead and take a look in terms of grid. Let's see if I have anything like that. I got UV grid, column grid, all that kind of stuff. Let me try polar. XYZ by polar coordinates. XYZ by polar coordinates. So what could we do there? Let's kind of take a look at what's in there. A radius, a rotation, and an offset. Okay, so we could go through and let's think about this. Rotation every 15 degrees. Let's try that. Let's see if we can make something work. Okay, so if we went through, and I'm going to do it in a new file, just because I think it'll be easier. You go ahead and save this away. Okay, simple. Okay, let's see how we could approach this. So let's go ahead and say, again, a new project. Architecture. Let's add in some Dynamo. And think about this. So if we went through and used that polar coordinates, let's think about it. So we need a radius. Let's start with that. Okay, some simple stuff. And we'll say num. And I don't know. We'll give it something simple like 10. XY rotation. Now that's kind of an interesting one about what it actually expects in there. And offset. Let's see if we can figure out what it does want. That's for doing that. My question is, what I'm sort of wondering about, XY rotation. Rotation around the z-axis in radians. Okay, that's good. So, which should the, okay, got it. So let's go ahead and put a number in there. Okay, so the rotation in radians. Okay, 2 pi r Right? No, that's okay. No, so radians. Oh, there's 2 pi radians. Is that correct? In a circle? Okay, so if I try that, oh, let's try like just 1. That should be, there's going to be like 6 of them or something like that going to be in the circle. Let's try that. And, oh, what would the offset be? Offset from the xy plane. Okay. We'll just go ahead and put it down at 0. Okay. Let's see how we're doing. Okay. Oh, that's a radius of 10, number 1. XY rotation. Rotation of the x-axis in radians.
I think this is only just 1 point.
That's just 1 point. Let's try giving it a number. Okay, so I see. Got it. Rotate in 5. Oh, I see. Okay, let's try something else. So let us go ahead and do a number series. Number slider. No, number range, number sequence. There we go. So let's try this. What if we actually start at 0 or start at 1? And let's call that up to 6. Why don't you like that? That's very strange looking. Copy. Okay, let's see what that does for us. Okay, that gives us, oh, okay. The step is 6, no worries. Okay. Let's try plugging those in as opposed to just a single number. Ah. That's getting a little more interesting. Okay, so that is, although it's interesting because, you know, if I really want them spaced around nicely, what I'd like to do is going to take like 2 pi and divide it by the number of spaces or something like that. Okay, so we can do something like that. Let's try this. Also, that's the radians there. What I'm wondering about is the radians. If I actually go through and plug in a couple of different numbers, if we can go through and kind of have concentric circles. So here's what I'm thinking about. Okay, again, as a number sequence here, as opposed to just sort of a single number there of 10. What if we started this as, we started at 10. Okay, we're going to go ahead and, oh, create like 3 of them. And use a step of 3. Let's try something like that. That looks like it's still just doing a single one because it's only taking, oh, I know why. It's because I have to try that. No, it's still just doing a single sort of set of coordinates. So I think we'd have to create a series of coordinates one step at a time. So we could go ahead and do this way. This way's not feeling so promising to this. I want to suggest a different way of doing this. Because I think there's another way that actually worked out pretty well too. Okay. If at first you don't succeed, panic not. We're going to go ahead and try a different strategy. Okay. Let's try this strategy instead. We could go ahead and actually use something we learned about last time, which is divide a curve up into a set number of points and use that as the basis for doing this. So let me try something a little bit different. Let's go ahead and we're just going to make a series of concentric circles. We're willing to try anything. It's interesting, it won't let me delete a bunch of them at once. We'll keep some numbers.
Use the delete button in the
That'll work?
where it works.
Excellent. Thank you. Let's go ahead. I'm going to start with just creating a little XYZ point. XYZs are always good. That's just going to be my origin. So the origin of my little coordinate system. And for that, I'll put 0, 0, 0 in there. Let's try that. And with any luck, we get a point in the center. Okay, now we would like to go through and create a circle. Okay, and I'd like that to be the center of the circle. Okay, and we need to go ahead and put some sort of radius on the circle. So let's go ahead and put a radius of like 5 on the circle. Got that. Let's try this. What would happen if we put in a series of different radiuses? I know if I put in a series of different XYZs, it'll create a series of different circles. I'm sort of curious about what it'll do. Or we might have to go through and, well, we'll see. How this has to be. Okay, because we could do it, yeah, well, we'll sort of see. We'll say number series. Okay, so we'll start at 5. We'll do 5 of them, actually going at 5 each time. Let's see how that works. And let me try plugging that in for the radius instead. Ooh, that wasn't too bad. That was better than I thought it'd be. Okay, so given that, we could go ahead now and start putting in some sliders here to kind of help us just kind of give a little more control over it. If I still want to start at 5, that's fine. Maybe I can sort of control the number of circles, so I might put in an integer slider to do that. And I'll say that basically, oh, maybe up to 10 of those. Let's see how that does. So I can go all the way down from 1 circle, 0 circles. That's kind of interesting. All the way up to 10 circles. Maybe I'll make the lower bound 1, just so it sort of makes sense. Not too bad. And then in terms of the step, that's the amount of space between all the circles. That could again be an integer slider, or you could just make that a number slider. And again, it probably wants to be at least something. So depending on whether we want a large range, bigger spacing. Okay, we got a pretty good, like a little just polar system right now. And our polar system is actually looking pretty good, except for the fact that it only has a single point on it. We'd like to have a bunch of points into it too. Okay, so let's think about that. Okay, what we'd like to do, I got some spare numbers hanging around over here, is I got all these circles over here. So let's go ahead now and add something that's going to actually divide a curve up into a number of points. So that's actually kind of a really useful way of doing it. The problem with my whole doing it by radians is since it's 3.14, 6.28, even though I put whole integers in there, something, they don't really kind of end up at very nice points along the circle. So if I actually do use this divide function, I think we'll be a little bit better. And, oh, what is it? Sort of, there it is. XYZ array on curve. let's see if we can figure this out. So if I go ahead and just plug the circle in as the curve, and then I give it some sort of count for the number of points, and again, that could be a nice integer slider or something like that. Okay, now I'm pretty good. Okay, so I could go ahead and start creating more of this polar array. In terms of what's going on. So that feels a little bit better in terms of giving us a little more flexibility. Okay, how's that feeling? Pretty good? Great. Okay, let's do this. Let us break for 5. Come on back. And when we do, we'll add some kind of just objects in here and kind of play with their heights a little bit. Then we'll go ahead and take a look at this issue of the curves and subdividing a surface and stuff like that. But I think that hopefully this will give you a pretty good sense of how to get started with the assignment. And it's not so bad. I think you're sort of seeing that I end up playing, going down a lot of little dead ends, backing off a little bit, but hopefully don't get too far lost along the way. Okay, so come on back in 5.